I've already made several videos discussing how to migrate to an HDR workflow within Davinci Resolve. However, as it turns out, and this was news to me, there are actually other programs besides Resolve that people use for post-production. Crazy, right? While Resolve is the industry standard for color grading work, and my personal choice when it comes to editing and delivery, the reality is that at some point you're going to have to figure out how to incorporate other software into your post-production workflow. For example, in addition to Resolve, I use Blender for 3D animation and Adobe After Effects for 2D graphics and compositing. So even after I moved to a color-managed workflow within Resolve, there was still the question of how to make HDR work across all of the software that I use. So today we're jumping head first down the rabbit hole of inter-application color management. So this video is going to be a follow-up to some previous videos that I've made concerning color management and how to apply it to an HDR workflow. If you have no idea what I'm talking about, or if you feel like you need a refresher on some of those topics, then I recommend that you go back and watch the videos that I'll have linked in the description down below. Alright, so to get started, let's define a scenario that we can use as a test case for a prospective HDR workflow. Let's say we have some live action footage recorded using a log format, and we want to composite some 3D element into that shot. So we'll need to go ahead and convert the source footage from log into something else, create a 3D element using Blender, composite the two shots together using After Effects, and then finally grade the shot and deliver it using Davinci Resolve. So how do we do all that while maintaining accurate HDR color throughout every step of the process? I mean, sure, we could just do all of the graphics in SDR as usual, and then use Resolve's Rec. 709 input transform to convert it to HDR. But that's not a very good solution if we want to make proper use of the HDR container. In Resolve, we maintain color accuracy using color management, but that process becomes a lot more complicated when other software gets involved. See, while Blender and After Effects do have their own built-in color management systems, they won't necessarily play nice with Resolve or each other. While color management systems are designed to be internally consistent within themselves, they won't necessarily produce identical results to one another. Different color management systems will interpret color slightly differently, so mixing and matching systems with differing transforms can lead to some distortion. You might think that the answer is simple, just use the same system across all three applications. But unfortunately, that isn't possible. Resolve does offer the user a choice between Resolve Color Management and ACES, but Blender can only use an open source library called OpenColor.io, and After Effects uses Adobe's own proprietary system, which doesn't exist outside their ecosystem. In short, there is no way to make these three programs use identical color space transforms to one another. In order to solve this problem, we're going to turn to an industry standard workflow called ACES. I've talked about ACES before in my video about color management, but I'll recap the important parts here as well. Basically, the ACES workflow works like this. Once we have all of our source footage collected, we use a color space transform to convert it all to a single standardized format called ACES 2065-1, or just ACES since that's a bit of a mouthful. ACES 2065-1 is what's called a scene-referred format, as opposed to a display-referred format. Display-referred formats like Rec. 709, DCI-P3, or most camera log formats use some sort of gamma curve to squeeze the signal into a fixed range. 0% is pure black, 100% is pure white. Anything below 0 or above 100 is usually not allowed. So we have to design a gamma curve which takes the characteristics of the image and those of the display into account in order to achieve ideal results. A scene-referred format like ACES is different. It doesn't care about the capabilities of the camera or the display. Instead, it seeks to record the color information as it would exist in the physical world. without any bias towards a particular display standard. It does this by using linear, floating point encoding paired with a wide color gamut. So what do those words mean? Well, linear just means that ACES doesn't use a gamma curve when encoding the image. A doubling of luminance in the real world always correlates to a doubling of the value recorded into the file, which isn't the case when using a display-referred format. But if there's no gamma curve compressing the highlights of the image, then shouldn't the dynamic range of the image be awful? Well, yes, it would be, if the image were encoded in the same way that display-referred images are. However, scene-referred formats aren't subject to the limitations of the 0% to 100% scale. Instead, they utilize floating point encoding. Floats are a big computer science-y topic, but you can think of them as being sort of like scientific notation. The order of magnitude of the number is stored separately from the number itself. Using more decimal places allows us to write the number with greater precision, but if we need to, we can represent an arbitrarily large number in a very compact space. Floating point encoding is a similar concept, with the only major difference being that the numbers are stored in binary rather than decimal. Using floats, we can store an arbitrarily large or small value within a predefined space, which is all we need to facilitate proper encoding within a computer. So while a linear gamma would lead to clipping in a display-referred format, floating point encoding means that no values will ever clip, no matter how bright or dark they get. You could represent 100 nits, 1,000 nits, a billion nits, or -50 nits. Floats don't care. So a scene-referred image has effectively unlimited dynamic range. We don't need to use a gamma curve. Additionally, ACES uses an extremely wide color gamut called AP0, which, while not technically unlimited, encompasses every color visible to the average human eye. So since the ACES format isn't biased in favor of any particular display standard, we can use it to pass images between applications without incurring any meaningful loss of dynamic range, bit depth, or color gamut. In an ACES workflow, we convert all of our source footage to ACES right at the start of post-production, and keep it in a scene-referred format all the way up until the final export. Then, as the last step of the process, we can apply an output transform to convert the image to a display format of choice, be that SDR or HDR. Now, of course, if we keep our image in a scene-referred format, then it isn't going to look right on our display. But we can have the software temporarily apply an output transform to allow us to see what we're looking at, while still keeping the image scene-referred under the hood. And this is how we'll solve the problems that come along with using different color management systems. We'll do both the initial input transform and the final output transform within Resolve, because those are the only two transforms which will permanently affect the image. We can let Blender and After Effects apply a temporary viewer transform using a different system, because that transform won't actually distort the final image. So with all that in mind, let's go ahead and go through the process step by step. Alright, so let's assume that we already have our clip imported into Resolve and placed on the timeline. So the first thing we're going to do after that is we're going to set up Resolve's color management to use an ACES workflow. And to do that, we're going to go up into the project settings here and go to color management. We're going to go ahead and change the color science dropdown here to ACES CCT. Well, you could theoretically use Resolve color management as well. Since we're going to be adhering to an ACES workflow anyway, it just makes more sense to use the tools specifically designed for it. Now, for the moment, we're actually going to set both our input transform and our output transform to none, because right now we're just trying to perform the initial conversion from log to ACES. Alright, so we're going to go ahead and hit save. And the next thing we're going to want to do is we're going to right-click on our clip in the media pool, and we're going to open up ACES input transform, and we're going to set this to whatever format our footage happens to be in. So in this case, it is Sony S-Log3 S-Gamut3 Cine. And this is going to tell Resolve to convert the clip from log to ACES. Now you'll notice that the image in our viewer doesn't look right at all, and that's because we don't have an output transform applied to convert from ACES to Rec. 709. We're looking at the pure scene referred image, which isn't designed to be viewed on a display directly. But now that our clip has been converted to ACES, we can get ready to export it from Resolve for use in our other programs. To do this, we're going to go ahead and go over to the Deliver tab, and we'll make sure that the clip in question has been selected. Next, you're going to want to make sure to set the format to EXR. Remember, in order to encode a scene referred image properly, we need to use floating point encoding. Traditional codecs like ProRes or H.264 are designed for display referred images, so they don't have the ability to use floats. OpenEXR, however, is designed for exactly this purpose. It utilizes either 16-bit or 32-bit float encoding and is the industry standard for exchanging high dynamic range images. Okay, so with OpenEXR selected, we can go ahead and export our clip. One thing to note is that exporting to EXR will create an image sequence rather than a single file, so make sure you create a folder to save your clip in. Once that's completed, we can move on to Blender. Alright, so as I mentioned earlier, Blender actually does have a color management system baked in. However, the default configuration is a bit limited and lacks some of the transforms that we'll need for this project. Thankfully, since Blender is open source software, the community has developed additional configuration options for it, which unlock a greater array of transforms. So we're going to need to navigate to this directory within Blender's program files. This color management folder contains the definitions for all of Blender's color space transforms, and we're going to replace this folder with a different one which I'll have linked down below. It's probably a good idea to back up this default configuration first, so we'll go ahead and make a copy of it here. Next, go ahead and download the community-made configuration files and extract them. We're going to go ahead and empty out the default color management folder and replace the contents with what's inside this download. Alright, so with that done, we're going to go ahead and restart Blender. Alright, so now let's take a look and see what's different. If we open up the Render Properties tab and scroll down to Color Management, we can see that some changes have been made. The default Filmic Log viewer transforms have been replaced, as have the options for sequencer and display devices. It's okay to leave all of this at its default. Basically, Blender is going to use a format called ACES CG on the back end, but convert it to sRGB on the fly. ACES CG is very similar to the ACES 2065-1 format that I talked about earlier. It's also scene referred with linear floating point encoding. The only difference is that ACES CG uses a slightly smaller color gamut called AP1. The AP1 gamut is still larger than Rec. 2020, but it isn't quite as huge as AP0. This makes it easier for graphic artists to do things like choose colors from a color wheel without accidentally choosing such an intense shade of green that the human eye is incapable of perceiving it. And this is why ACES CG is typically used for graphics work and other visual effects. Alright, so now we want to make a 3D element to add to our source clip. So let's go ahead and import our clip to use as a reference. We're going to select the camera and go into our camera settings and check background images. Next, we're going to go ahead and hit add image. We're going to change it to movie clip. And we're going to go ahead and select the EXR sequence that we rendered out of Resolve. Now we're going to want to make sure that the color space here is set to ACES 2065-1, since that's what we exported from Resolve. We can also go ahead and turn the opacity up to 100% if we want to, and decide if we want the clip to appear in front of or behind our scene. Alright, so now we're free to go ahead and create our 3D scene however we want to. And in my case, I went ahead and imported some camera tracking data from After Effects, and then I added a little monkey head into our scene here with appropriate lighting and everything like that. One thing to note though is that if your project involves importing image textures, then you're going to need to set the color space correctly on each one. Most of the time you're going to want to select either Utility sRGB Texture for a normal image texture, or roll data if the texture is something like a normal map or a bump map. All right, so once we're done creating our 3D element, it's time to export it. So we're gonna go ahead and go into Output Properties, and we're going to select OpenEXR as our file format. Then just go ahead and choose an output folder and render the scene as you normally would. Since Blender uses a scene-referred pipeline behind the scenes, you don't actually need to do anything special in order to create an HDR image. If you have a bright light in your scene, it'll utilize as much of the HDR range as it needs to. This is the advantage of working in a scene-referred space. Okay, so now we have our two elements, our source footage and our 3D asset. The next step is to composite the two together using Adobe After Effects. Now, just like Blender and Resolve, After Effects also has a color management system built in. However, there's a problem. Resolve's ACES library and Blender's OpenColor.io library produce results that are similar enough to one another that we can mix them without too much issue. However, Adobe's color management system produces results that are significantly different from either of the other systems. We could use the built-in system, but what we saw in the viewer would end up looking quite different from what would show up in Resolve. We want to be able to see what we're looking at properly, so this isn't a good option. Thankfully, once again, there is a community-made solution. There is a plugin which will allow us to use OpenColor.io transforms within After Effects. Great, so now we can go ahead and set up our project. Okay, so let's start by importing the two OpenEXR sequences that were created in Blender and Resolve respectively. So we can see we have our original here, and then we have our Blender element that we created on top of that. Now by default, After Effects will recognize these as scene-referred images and try to convert them to Rec. 709 for us using its own color management. But we don't want that. So we'll essentially need to lobotomize the built-in color management and tell it not to perform any transforms whatsoever. Okay, so in each one of our clips here, we're going to right-click, hit Interpret Footage, Main. And then we're going to go over to the Color Management tab and hit Preserve RGB. This will force After Effects not to use any color space transforms when interpreting these clips. And then of course we're going to do that on the other clip as well. Next, we need to open our composition and go into Set Project Working Space. Make sure that the Working Space option is set to None. This will once again prevent After Effects from performing color space conversions automatically. However, we do want to make sure that the depth is set to 32-bit float. Okay, so now we can see that our clips are being left alone in their original scene-referred state. Now that After Effects color management has been disabled, we can start adding our own. So to do this, we're going to need to go ahead and install the OpenColor.io plugin, and I'll go ahead and I'll have that linked down below once again. So once you have that downloaded, we're just going to go ahead and drop the OpenColor.io plugin into the After Effects plugins folder here. And once the plugin is installed, what we're going to do is we're going to go ahead and create an adjustment layer and place that on top of the entire composition. Then we're going to go into our Effects tab, and we'll add the OpenColor.io plugin to the adjustment layer. And we're going to go ahead and select the ACES configuration here. And then we're going to leave the input space set as ACES 2065-1 because that's what our timeline is. And then we're going to change the output space to output Rec. 709. Now we can see that the composition is being converted to Rec. 709, and the results resemble those in Resolve much more closely. Great! Only one small problem. If we export our composition as is, then this output transform will be baked into the image, which isn't what we want. Thankfully, After Effects has a solution for us. So we're going to go ahead and select the adjustment layer again. We're going to go up into Layer, and we're going to select Guide Layer. A guide layer will only be visible in the preview window, but it'll be automatically disabled during rendering. So we can see the Rec. 709 conversion while we're working on the composition, but it won't have any effect on the rendered product. Now our output transform is assuming that all of our clips are ACES 2065, but you'll remember the clip we created by Blender is actually an ACES CG. So we'll need to apply a color space transform to perform the conversion. So to go ahead and add the OpenColor.io plugin to the Blender layer. And this time we're going to go ahead and set the input space to ACES CG. The difference may be subtle in this case, but this step is even more important when you need to bring in something like a plain sRGB image or something like that. Once we're done compositing the shot, it's time to export it one last time. So we're going to add the composition to our render queue just like we normally would. But don't click render right away. We need to click on the output module and set the format to OpenEXR. But, and this is very important, we also need to go over to the color management tab and click on preserve RGB one last time. After Effects thinks it knows better than us, so it's going to assume that our timeline is Rec 709 and needs to be converted to linear for OpenEXR export. So we need to tell it one more time that no, we really don't want it to apply any color space transforms. Please, just don't apply any. I've told you like 3 times now. Anyway. So with that selected, we can go ahead and render our composition one last time to yet another OpenEXR sequence. Alright, so finally all we have to do is bring our completed shot into Resolve and prepare it for delivery. So I went ahead and imported the OpenEXR sequence that I just exported from After Effects, and the next thing we're going to do is we're going to double check that our color management settings are correct. So in our project settings, we want to make sure that the input transform is set to none, and the output transform is set to Rec 709. And we can double check that on a per clip level here. Our original clip is still set to S-log3, and then our clip from After Effects here is set to none, and that's exactly what it should be. And now if we go ahead and compare the 2 clips side by side, we can see that the colors are identical. They've successfully been carried over throughout the entire process without any distortion. The only difference between the 2 clips is the 3D element that we added. So great, congratulations! Now we're free to go ahead and grade the clip however we want to, and then export it as either HDR or SDR, just like we normally would. And so there we have it. Using this workflow, we can work in an HDR environment in any compatible program. Now, even though I only demonstrated how to use an ACES workflow in 2 other programs, most professional graphic software will likely support something similar to what I used here. Once you understand the fundamentals, it's only a matter of researching how color management works in your program of choice. Now, I've been using this workflow myself for the past several months, and it's been working quite well for me. So anyways, I hope you all enjoyed this video. My name is Cayman Crocker, signing off.